Welcome to Maths with EJD. In this video, I'll be talking about sensitivity analysis in linear programming. Now, this is an introduction to sensitivity analysis. I'll be making a video after this one to, actually look at practical examples. Okay, we need to know that sensitivity analysis is crucial is a crucial technique. It's a crucial technique used in optimization, especially linear programming, to understand how variations in the parameters of a model affect the optimal solution. It involves examining the effects of changes in the objective coefficients changes in the objective coefficients and constraint limits on the optimal solution of an optimization problem. Okay. In linear programming, we often deal with an objective function that needs to be maximized or minimized subject to certain constraints. I mean, subject to certain constraints, right? Now, the solution to this, the solution to this problem is highly dependent on the values, on the values of the coefficients in the objective function. And of course, the constraint limits. Okay, so I mean, these two parts now, the values of the coefficients in the objective function, and of course, the constraint limits. These are two key areas that determine what the result looks like. And that is the target of sensitivity analysis. So sensitivity analysis, okay, I guess I want to change now. Sensitivity analysis, sensitivity analysis helps to determine the extent to which these values can change without altering the optimal solution, or identifying how they will change the optimal solution if they did. Okay. Now let's look at we said it already that the coefficients in the objective function and the constraint limit are the key things that determine the nature of problems. So let's talk about impacts. Impacts of changes in objective coefficients. Okay. Because the objective coefficients in a linear programming model define the contribution of each decision variable to the objective function. So a change in these coefficients can significantly impact the optimal solution. So that's one. Okay. Now, through sensitivity analysis, right? Through through sensitivity analysis, through sensitivity analysis, we determine the range within which the objective coefficients can change without without altering without altering the optimal solution. So range is keyword here. Without altering the optimal solution. Now this is called the sensitivity range. The sensitivity range or range of optimality. range of optimality. Okay. Hmm. Okay, let's look at an example actually. Let's look at an example for this. Imagine this. Okay. Suppose we are solving a linear programming problem where the objective is to maximize profit by producing two products, A and B. The objective function might be, the objective function might be something like maximize Z, which equals 5x1, 5x1 plus 4x2, where x1 and x2 represent the number of units of products A and B to produce respectively. Okay. Then the coefficients 5 and 4. The coefficients 5 and 4, this and this now. The coefficients 5 and 4 represent the profit per unit of products A and B. Okay. Now, when we talk about sensitivity analysis, right? So, how do we talk about the sensitivity analysis in this situation? Focusing on the coefficients, right? So, imagine case one. Okay. I guess I want to change color now. So, let's talk about the sensitivity analysis of the sensitivity analysis. So, imagine case one. What if the profit for products for product A changes from 5 to 6? Okay. Imagine the profit we had before. Z is 5x1 plus 4x2. So that now changes to, let's say Z prime equals 6x1 to 4x2. How does it affect the situation? That's basically what we are thinking about now. So here, so you see that this change, right? This change increases the profits. This change increases the profit for product A, which could make it more profitable to produce A than to produce product A than product B, right? Normally. So potentially, potentially leading, potentially leading to a different optimal solution, possibly a different optimal solution. So because of that, now we would reevaluate, the values of x1 and x2 to determine the impact, okay? To determine the impact. It's more like, if you have solved the problem and you've got an optimal solution, you know, uh, you want to, so by the time this change happens, you want to actually reevaluate, carry out the process again to see the impact of this change. So imagine case two. Okay, so what if the profit for product B decreases from 4 to 3. Okay. That's sensitivity analysis right there. So you have 5x1 plus 4x3. I mean to 4 plus 4x2. Now that is changing. That is changing to say z prime is now 5x1 plus 3x2. So the profit of item product 2 is decreasing. So basically, you see the production of product B would become less attractive, right? It will become less attractive, possibly decreasing the number of units of B produced, and the units and the units of product B produced, and increasing the units of product B, of product A rather, of product A in the optimal solution. Because now A makes better profit. Okay. So that's one part of the sensitivity analysis, right? Um, what if the profit for product A changes from 5 to 6? Now, let's look at impact of changes in constraint limits. We have just considered impact of changes in objective coefficients. So let's look at impact of changes, in constraint limits. Okay. Now, like we know, constraints define the feasible region. Constraints define the feasible region in optimization problems. In constraints define the feasible region in an optimization problem. Okay. So changes in constraint limits these are the left-hand side values. Okay. These are the right-hand side values. They fall under simplex method. So these are right-hand side values. Changes in constraint limits can actually shift. It can shift this feasible region. It can shift the feasible region, potentially altering the optimal solution. So it can either probably extend the feasible region or shorten it. So thereby altering the optimal solution. Okay. So similar, similar to the objective coefficient, right? Similar to the objective coefficients, changes in constraints, changes in constraint limits are evaluated within sensitivity ranges to determine how much, how much the limits can vary without changing the feasibility or without changing the feasibility or optimality optimality of the solution. Okay. These ranges are often often referred often referred to as the range of feasibility. Range of feasibility. Now, in the case of constraints, in the case of coefficient, right, we're talking about the range of optimality. So for constraints, you have the range of optimality or sensitivity range, whereas here we talk about the range of feasibility, talking about the constraint limits. Okay. Now let's look at the case we considered the other time, right? That example again. Example, imagine the same problem, consider a resource allocation problem, a resource allocation problem where we have two constraints, where we have two constraints. Okay, say 2x1 plus 3x2 is less than or equal to 12. That's for resource one. That's for resource one. And then we have x1 plus 2x2 is less than or equal to 8 for resource 2. Okay. Now, the objective function is still the same like before. The objective is still to maximize. The objective is still to maximize z equals 5x1 plus 4x2. Okay. Now, if you consider the sensitivity analysis, see what happens. Sensitivity analysis. Okay. Now, let's look at two cases again. First, case one. Case one, the question is, what if the limit for resource one, what if the limit for resource one increases from 12 to 14? Okay. So more like we have a wider range now. What that means is that the first constraint, 2x1 plus 3x2 is less than or equal to 12. Now changes to 2x1 plus 3x2 is less than or equal to 14. Okay. So that way, the range is wider now. You have a wider range to follow. So what is going to happen in that case is that the feasible region, right? The feasible region expands. feasible region expands, which which could potentially which could potentially allow for more production. So you can have more production of both products A and B. So we can now check. So we would check the feasible solution. We check the feasible solution to see if the optimal production, if the optimal production mix changes. Now, the idea here is that when you have the original problem, when you have this original problem and you set up the simplex tableau and you do the optimal solution, you get your result for x1, x2, and you get your z, right? By the time this 12 now changes to 14, so you have to do the tableau again to see if the optimal solution remains the same or something has changed. Okay, so that is the idea. And in the next video, I'm going to do something practical. Now, since I've already uh, talked a lot about simplex method, I may not just do the simplex thing. I'll just give you the results and then try to do the explanation because the focus is on sensitivity in this case. Now, let's talk about case two. Let's talk about case two and see another issue. Imagine this. What if the limit for resource two, two constraints, resource two is the second one. What if the limit for resource two decreases from 8 to 6? That will shrink the feasibility region in a way. So the second constraint now, which is x1 plus 2x2 less than or equal to 8. x1 plus 2x2 is less than or equal to 8. Now becomes x1 plus 2x2, is less than or equal to 6. So automatically, the feasibility region is affected a little bit. So this would shrink the feasible region, the feasible region, and might force the optimal solution, force the optimal solution to I might force the optimal solution to reduce the production of product A or B to meet the new constraints, Okay, so that is possible. So in the next video, we are going to see this in a better light. Now let's talk about some practical applications. Practical application of sensitivity analysis. Sensitivity analysis. Okay, let me not be miserly with that. Of sensitivity analysis. Okay. Yeah. So let's see this. Sensitivity analysis is commonly used in various fields like operations research, economics, and management science to guide decision making under uncertainty. Okay. Of course, we have practical situations like uh, production planning. So in production planning, businesses might use sensitivity analysis to determine how variations in labor availability or material costs affect their production schedule. Okay. Then we also have in financial planning, sensitivity analysis, sensitivity analysis helps investors understand how understand how fluctuations in interest rates or inflation could affect investment returns. In fact, the next video is going to be focused on uh, portfolio optimization. So watch out for that. Then we can talk about resource allocation. In resource allocation, just like the one we just considered now, in resource allocation, organizations organizations use sensitivity analysis to evaluate how changes in resource limits, e.g. budget, e.g. budget, budget, time or manpower impact the overall efficiency of project outcomes. So, in conclusion, right? In conclusion, sensitivity analysis provides valuable insights into the robustness, into the robustness of an optimization solution. So, I mean, you only carry a sensitivity analysis after you have got your optimal solution. So, sensitivity analysis is just checking out how robust that optimal solution is like, you know. So, by understanding how changes, how changes in objective function, in coefficients, objective coefficient. I think I need to emphasize this too again. By understanding how changes in coefficients, objective coefficients, and constraint limits. These are the two key things. Objective coefficients and constraint limits. Understanding how changes in objective coefficients and constraint limits impact impact the optimal solution. Decision makers can better prepare better prepare for uncertainties better prepare for uncertainties, make more informed decisions, make more informed decisions, and adjust adjust their strategies in dynamic environments. That is changing environments, right? In dynamic environments. So, in short, right, you have you have a linear programming problem, you use whatever method, maybe graphical. In this case, the focus is on simplex. So you use your simplex method, you get the optimal tableau, you get the optimal solution for the decision variables, and of course, you get the value of the objective function. Having done that, then you now begin to think of, okay, what if some of the coefficients, some of the constraint objective coefficients change? Or what if some of the constraint limits change? How is it going to affect the optimal solution you've got already? So from there, you can try to understand, maybe you can make better decisions, right? Like you're making some investments, and by this sensitivity analysis, more like you're tweaking the solution you already have to see if you can actually get better situations. So I'm going to stop here. If you have not subscribed to this channel, be sure to do that because there's a lot to learn here, a whole lot. There's a lot done already and a lot more is coming. So you don't want to miss out on any of these things. So subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. And don't forget to comment. Let me know if you need me to teach a topic or you need me to answer a particular question, to solve a problem that is. And don't forget to like and share so that more people can have access to this great content. So like come your way again. So next I'm coming up with actual practical solutions which will involve actual problems like that. You know. Till then, keep optimizing. Bye.